Have you tried to answer the questions? What happened to the gut? And why did the people who were assisting him lift up his legs? Okay, in fact, what happened, what the gut had experienced when he fainted, because all the blood, right, was accumulated at the leg region. So by helping him to lift his legs, it's helped to actually recirculate the blood, right, back to the brain, the head region, so that he got sufficient blood, okay, and he will not faint that easily. So for this guy, I actually suspected he did not have enough training. So due to the he did not have enough training, so this such thing happened to him quite often. Okay, so but other than that, let's say you are standing still for a long period of time, or let's say you are on a plane where you cannot, mobility is limited, you should still try to move your legs every now and then, so that you won't experience such a condition known as venous pooling. Okay, where all the blood, right, will be actually accumulated at the leg region. Right. So this was actually what was covered the last lesson. So let's continue. So we learn more about the arteries, the veins, and now moving on, right, we have this last bit about capillaries. Right, so we're going to look at the structure of capillaries, the function, and how does the exchange of material that happen between the tissue and the capillary base. Right, so the capillary. So in fact, the capillaries is only one layer of cells. So can you imagine? It's a very thin layer. It's really like a popiah skin, just one thin layer. Okay, it's one thin layer. Okay, of cells. The cells is actually known as endothelium. Okay, and so this is how it looks like. You can see it's one layer of cells here. Can you see this one cell, another cell, third cell, fourth cell, fifth cell? These are all cells, one layer of cells, and they it's actually have a lot of branching. So from this one capillary will further branch. There's a lot of branching, just like our tree. Okay, there's a lot of branching to actually increase the total surface area to volume ratio. So there's a higher surface area to have allow a more efficient exchange of substances between the blood and the cells. Okay, so it's actually a network of microscopic vessel, very, very tiny. Okay, so this is the capillary, very, very tiny over here, branching. It's usually at the organs. It's one cell thick. So what happens is that because it's one cell thick, it allows the oxygen and other useful substances from the blood and the capillary to diffuse into the surrounding cells. Okay, the surrounding cells surrounding the blood capillary by diffusion. Okay, there's this picture here. Let me move away by this icon over here. So you can see this is all the capillaries, and the surrounding are all these individual cells over here, tissue cells, right? So okay, so it allows the exchange of substances, is partially permeable, not partially permeable, allows certain substances to diffuse through, and it has a narrow diameter, increase the resistance, and helps to decrease in the blood pressure. Because the blood pressure here must be slower, so that there's allow sufficient time for the exchange of substances from the blood here to the surrounding cells. And due to the largest cross-sectional area, it actually helped to create a larger surface area, and this helped to have a larger amount of exchange of substances within a shorter period of time, a greater exchange of substances. Right, there's a hanging here. I'm not sure what happened. I cannot go to the next slide. I will stop my sharing. I will continue with the next video.